This video is on compound interest, and before we go through the lesson material, here's a video I found on the internet for you.
Would you rather work hard for money or have money work hard for you? Compound interest empowers you with that choice. Compound interest is a core financial principle that can drastically increase your wealth over time. But before we explore compound interest, it's helpful to understand simple interest. Simple interest is the interest you earn on just your principal. Let's say you invest $1,000 and earn 5% simple interest for 5 years. In year 1, you'll earn $50, which is 5% of your $1,000 principal. In year 2, you'll earn another $50, and each year thereafter, you'll continue earning $50. As you can see, simple interest remains constant over time. Compound interest is a different story. Let's say you invest your $1,000 in a savings account that compounds annually with interest of 5%. In year 1, your interest is still $50. However, assuming you keep your interest earnings in your account, your dollar interest will increase every year. In year 2, you'll earn $52.50. In year 3, you'll earn $55.13. Why? Because you're adding your interest to your principal each year. So you're earning 5% on a perpetually increasing amount of money. Compared to our first example, you earned an additional $26.28 of interest, or 10.5% more, over the same time frame. This growth is known as compound interest, which enables you to build wealth without lifting a finger. As the name implies, compound interest is the idea of interest on interest, which occurs when you reinvest interest earnings to make more money. So long as you continue to reinvent your interest, your passive income will exponentially grow.
So let's continue with compound interest. Here we have Jack, who has invested $4,000 for 3 years at 5% per annum, compounded annually. This compounded annually means the interest is paid at the end of every year. So how much will he have at the end of the 3 years? So think of this as a bank statement where on the 25th of October 2017, Jack has deposited $4,000, so his balance is $4,000. So 1 year later, his bank will pay him some interest. Now, how much will they pay? 5%. So the interest would be 5% now. 0.05, we multiply by 4,000, and we get $200. So his bank balance statement would be $4,000 plus the 200. So 4,200. Now, if this was simple interest, he would get paid $200 interest every year. But it doesn't work that way with compound interest. In the next year, he will get paid 5%, but not of $4,000, no, 5% of his new balance, which is 5% of 4,200. And that gives him an interest that year of $210. Can you see how the interest is increasing? First it was 200, now it's 210. Well, let's keep going here. How much would his balance be now? Well, if we do 4,200 plus 210, that gives us $4,410. Now, third and last year, 5% of 4,410, which gives us $220.50. So his new balance is $4,630.50. So in this case, Jack started with 4,000, ended up with this much. What is his interest? The interest the bank paid him in total. It's how much he ended up with minus how much he started with, which is, in this case, $630.50. Now, are we going to do a table every time? No way. So in your journal, could you please write down the title, which is compound interest? Write down this formula. Notice that there's a number 1 in the formula, and that number 1 always appears in the formula. And let's quickly go through what each single one of these things means. First of all, FV stands for future value, how much money you'll have in the future. PV, how much money you have now in the present value. I, it's the rate of interest per compounding period as a decimal. Oh, a lot of information here. We'll go through what this means in the next example. N is related to time, but it's not simply number of years. It's the number of compounding periods. That's a strange thing. What does this even mean? Well, if you would like to write it next to it, it just means it's the number of times interest is paid. Number of times, interest is paid. And the last formula to write down in your journal, could you please write down I for interest is equal to how much money you will have in the future minus how much money you started with. So I is equal to future value minus present value. So if you want to pause this video, if it makes it a bit easier for you to copy down notes, and then move on to the next part. Here we go. We have Jack again. This time we're not going to use a table. We are going to use a formula, which is that. So let's start. PV. PV is the present value. Jack started with $4,000. Next one, I. I is the rate of interest per compounding period as a decimal. Now, this means that you ask yourself, how often are we getting paid interest in this question? The interest is paid annually. And the interest rate was 5% per annum, which was 5% per year. In this case, the I, you change it into a decimal, 0.05, and you're getting paid 5% every year, every time you get paid interest. So in this case, the I will stay as 5%, 0.05. In the next lesson, we'll go through other cases, for example, when it's compounded monthly and so on. And N. N is the number of compounding periods. How often do we get paid interest? Every year. Oh, the money stays there for 3 years. So how many times would we get paid interest? Get paid interest 3 times. And that's our N, 3. So now we're going to put these values in our formula, FE for future value, and we put them in. And I would like you to now put this in your calculator and have a go at putting that. Now, if you are not sure how to put that cube there, that 3, look for the button which is a hat in your calculator and see what you're getting. And hopefully you'll get this number, $4,630.50. Now there was another formula that we had at the end of the last slide, which was this one here, down the bottom, FV minus PV. So if the question is asking us how much money will he have at the end of the 3 years, this is the final answer. If the question had been how much money will he make, how much money will he make, how much interest would he earn? In this case, it would have been FV minus PV. And we put it down, and just like before, it's $630.50. Now when you're doing these compound interest questions from the textbook, use the formula for only one of the questions. Now for the other ones, you're allowed to use your graphics calculator, and I'll show you now how to use it. So please get your graphics calculator, and remember it's a requirement that you do have one by now, and if you don't, please inform your parents that you'll need one. So if you go to the menu screen and press where it says financial, and we go execute there. Now, I'm pressing exit. There was something else on my screen. So press exit if you had something different. And we're looking for compound interest. So that is for F2. We're pressing F2 there. Now, I've got some random numbers here on my calculator, and I left them like that on purpose because you might have other numbers and you will always get different numbers. So we just have to type over them. So what you should do is whenever you're using your graphics calculator, straight away, if you go down, you'll notice that there's a number of things here. There's N, I, and so on. And it stops at C per year. And we'll see what that means. So whenever you're answering these questions and you're using your graphics calculator, I recommend that you write, well, I don't recommend, you should, you must write down all of this that we see in the graphics calculator. Now, what do we actually type in our graphics calculator? Well, N is the number of times you get paid interest. We got paid interest 3 times here. It was compounded annually. It stays there for 3 years. So we type in the 3, put the 3 there, and execute. Now, we do not have to do any type of working out for the interest. They told us it was 5% per annum, and that's what we type in. We type in 5. Next one, present value. This is when it gets tricky now. See how we invested $4,000? You think of it like the money. At the start of that time, did Jack give the money to the bank, or did he take that money away from the bank? Since the money was leaving Jack, we need to put a negative there as our present value. This is negative $4,000. Next step, we have PMT. Now, are we adding any extra money ourselves into that bank account? Are we taking any money away from the bank on a constant, regular basis? No. So in year 11, that payment stays as 0. Future value is what we're trying to work out. Doesn't matter what it says there. You could say 0, you could say anything else. We'll come back to it. That stands for payments per year. Now, technically, we are not adding any money to this bank account, but how many times does interest get paid into our account per year? How many times is interest paid per year into our account? It's compounded annually, so we get paid interest once. So simply put in there a 1 there, and you notice that straight away the compounding periods per year change to 1 as well. So what we will do is we go and write down all of this information. We would write it down. So we put here N, which is 3 times. So, oops, that's not working. So 3. I, we said was 5. Present value, it was minus 4,000 because I'm depositing that money. It's leaving me for now. Payment, we said was 0. Future value is what we're trying to work out. I'm going to put a question mark. And the payments per year. It's compounded annually. I get paid interest once per year. So going back to the calculator, we are trying to work out future value. And I'm looking down here, future value, my F's. That is F5. I press it, and it's telling me that my future value, my future value is $4,630.50. And that is what I would write down in my working out. FV, 630 and 50 cents. And the calculator does it straight away for us. We'll practice once more with another example with our graphics calculator. So here we have, it's telling us find Tomiko's final bank balance if she invests $10,000 in an account at 3.6% per annum compounded annually for 15 years. Since we're using our calculator, we must write in our journal, not in a journal exercise book, all of this. And let's start by writing it down. So N, how many times do we get paid interest? Well, it's compounded annually, so we get paid interest once every year, and it's going to stay there for 15 years. So N is 15. I, interest rate, 3.6. Present value. Now, we're investing 10,000. Was the money that she has at the start, is the money going towards her? So if this is the bank here, who's giving the money to whom? Is the bank giving her money? No. She is giving the money to the bank. The money is leaving her. That means the present value, she has it will be negative 10,000. If she was borrowing money from the bank, the present value would have been a positive number. So let's go and put PV minus 10,000. Remember, payment, we are not adding any money, we are not subtracting any money, so that's always going to be 0. Future value is what we're trying to work out in this case, question mark. Now, our interest is compounded annually. How many times does she get paid interest every year? It's only once per year, so we put the number 1 there. So if you have your calculator, please, we're going to use it again. So this is from our previous question. So we press exit, and you'll notice that the future value from the previous one appears there now. Well, we're going to type over it now. So go all the way to the top, and we start putting our numbers in. Notice my future value, it's got the previous answer. I'm just going to go over it, and we have the same one as payments per year and compound per year. So we press FV again, F5, and notice that it's a positive number just like before. This means that at the end of the 15 years, the bank will give her money back to her. So the money will flow from the bank to her, and that is how much money she will have at the end of the 15 years. So I've written down the future value there, and notice that we go 2 decimal places because it's to the nearest cent, since it's money. And now we're reaching the last question, and it says, 3 years ago, Holly invested an amount of money in an account paying 6.2% per annum interest compounded annually. Its value is now $5,497.77. How much did Holly invest? We're going to use the graphics calculator. And once again, we're going to have to write all of this down here. Now, let's look at this question. What is the question asking us? How much did she invest? Now, only because the value is now this much, we must not think of this value as the present value. No. 3 years ago, she started with some money. It then became that much. So you have to think of this as the future value. So down in future value, that is the number that we write down, 5497.77. The question is, how much money did she invest? In other words, how much money did she invest 3 years ago? How much did she have back then? That would have been the present value back then, and that is what we're trying to find. So N, how many times was she paid interest? How many years was the money left there? It was left there 3 years ago, and she got interest was compounded every year. So she got paid interest 3 times. The interest rate was 6.2. Payment again, always 0. And down here, the interest was compounded annually. You get paid interest only once per year. So now we put this in our calculator. This is our previous answer. So again, we press exit. Oops, no, there. And off you go. You can type them in as well. Present value, no, I'm going to skip that one. Future value. And the payments per year, compound per year has not changed. Now, since I'm looking for the present value, I need to look over here, present value, it's this one here, F3, which is that number. Now, notice how there's a negative there. When I write it down in my working out, I still include that negative value there in my statement then, but now I need to go and write down a little sentence that would say that Holly invested, and I do not write money with a negative sign, 590. Now it's 0.00, no need to put the cents there. So please ensure that when you are writing the sentence there, you do not include the negative. So we've reached the end of this video. So could you please go and do these questions that I have here on the screen there. Thank you.